Hi, everyone. My name is Prof Pillay, and I propose to run a series of sessions which deal with problems which were set by the South African Mathematics Foundation, whose website is www.samf.ac.za, where you will find a lot of information. The programs comprise of discussions on Olympiad problems, which were managed by the foundation from the years 2023 to 2025. And these include the round 2 and round 3 junior competitions, as well as round 2 senior competitions. In addition, I shall also be doing the so-called team competitions, which is run by the society over the same 3 years. And those competitions are for the junior and the senior. And there are two types of papers, individual and team. And with those few words, I would like to begin straight away with the very first topic. And we are going to do the 2023 Junior Round 2 paper. Seem to have some difficulty getting into this. Just one moment, please. Okay, here we are. All right, the very first question is the following. There's a calculation problem here, and it tests indices. And you will see that the numerator and the denominator have square roots in them. So you have square root of any number raised to the power of 0 is 1. So 2 to the 0 is 1, plus 2 cubed, which is 8, and the denominator is square root of, and the numerator is, the 2 to the power of 2 is 4, minus 3, and that immediately simplifies to 3. Okay, so that's the first problem. And here is I also have the solutions worked out, and okay, let's just get on to the next problem. Now, in all these problems, I've already worked out the solutions, and the idea in these presentations is to give a verbal report on those solutions, and much more can be said by expanding on the ideas that are contained in solving a particular problem. So you have a double benefit. You not only see the written solution, but also the verbal explanation. The second problem, there are 780 learners at a school. If there are 50 more girls than boys, how many boys are there in the school? All right, so this is a question where you can use symbols. There are two methods which I can suggest here. Where you use a symbol, you say, okay, you've got how many boys? So let X be equal to the number of boys. Right, so you have to solve for X. It says that there are 50 more girls than boys. So therefore the number of girls is 50 more than x, which is x plus 50. And altogether, there are 780 learners. And they comprise of the boys together with the girls. And when you add them up, you're supposed to get 780. And then when you solve for x, which you can do, you get 365. Okay, this is the first method, as I said. But there's another method which is a little bit deeper, but you see, there are 780 learners at the school, so half the learners is is 300, half the number of learners is 390, and you got 50 more girls than boys, so there are 25 below and 25 above, right? And the number of boys will be 29, 25, which is half of 50, because it's right in the middle, you see. So it's 390 minus 25. You'll end up with 365 again. Okay, and the number of girls will be 390 plus 25. All right, so there are two ways of solving that problem. And we can get on to problem number 3. This is the written solution for this problem. Problem number 3 is a problem in geometry, and we have the following in quadrilateral ABCD. As you can see, AB is equal to CD, and it's indicated like that with 2 strokes to show that they are the same. Angle CAD is 65 degrees. That's in the figure. BAC is 80, and so on. Right. And the question is determine angle ACD. So there's a question mark here. So we need to determine those angles, that particular angle. Well, it's quite easy to see. Where do we start? Well, we know that 2 angles of a triangle add up to 130 here, and the sum of all 3 angles is 180. So this must be 50. The moment you say this is 50, then you have an isosceles triangle, because the 2 angles of the triangle are the same, and therefore the sides opposite these angles are also the same. Right? An isosceles triangle has the sides equal together with the angles opposite them. So the sides opposite these equal angles is those 2. And now you see that this other triangle is now isosceles, which means that those 2 are equal. So therefore the angles opposite these equal sides must be equal. 65 is opposite that, and this angle will also be 65 because they are opposite equal sides. And then once you've got 2 angles, the third angle can be calculated to be 50 degrees. Okay, because all 3 angles add up to 180 degrees. Okay, so that takes care of problem 3. And here is the written solution. Okay, let's get on to the next one. A square of side length 4 is subdivided into 16 identical squares. All right, so you got a 4 by 4 grid, you call it a grid, and there are 16 smaller squares. So the side is 4, so each one is 1. So all these sides are equal to 1. So the question is, what is the shaded region? The shaded region looks rather weird. It's some kind of a jagged region here. And it's not easy to calculate the area here. You can see. You can, but some of them are half squares, some of them are some small fractions of squares, and so on. And it doesn't look as if we'll be able to solve it by doing that. But a little bit of thinking will tell you that if X is the shaded region, if X is the shaded area, and Y the unshaded area, that is the area which is in white, then X plus Y is the entire area, which is 16. All right, so that helps a great deal because the unshaded area is easy. It consists of 3 triangles, and you know the dimensions of these triangles. So this triangle here, the base is 1, and this is 4, and you know the area of a triangle is half base times height. So it's half 1 times 4, or if you like, it's half 4 times 1. In this triangle here, you got the base is half base times height. The base is 2 here, and the height is 3. You can see the height is 3. So that's easy enough to calculate. And here too, the base is 1 and the height is 2. All right, so you can calculate y easily. So this is 2 here, half of 4, and this is 3, and half of 2 is 1. So you go 2 plus 3 plus 1, which is 6. So therefore y is 6, and x is 16 minus y, which is 10. Okay, so that's the solution to problem number 4. Okay, let's just check to see whether this calculation is right. It agrees. Oh, yes, you can see here, the shaded area is indeed 10. So that's fine. Okay, so let's just get on to the next problem. Problem number 5. Problem number 5 says, the smallest whole number, what is the smallest whole number that 700 should be multiplied by to make it a perfect cube? Now, cube is a number times a number times a number. It's a number multiplied by itself 3 times. Okay, so you want to multiply 700 by something, let's call it x, so that the whole thing becomes a cube. All right. Now, at the moment, now to do that, let's factorize 700. 700 is 7 times 100. 100 is 10 times 10. And then if you factorize this, oh, I shouldn't say this looks like an x here. 7.10.10. That's 2 squared, 2 2's here, 5 squared times 7 times x. Now you want this to be a cube. So in other words, all these powers must be 3 or multiples of 3. So when you factorize it, each index or each exponent must be 3 or a multiple of 3. Since you want the smallest, so you want all of them to be 3. That's the smallest multiple of 3. So you got to do that, you'll see x will have to be, you have to add one more 2 to this. That 2 squared times 2 will give you 2 cubed. And you have to add one more 5 to this. That will make it 5 cubed. And then 7, you have to add to make it a cube, you have to put 7 squared. So that's how this product will now become a cube. And when you work this thing out, you get 490. So that is your x. So in fact, 700 times x will be 2 times 5 times 7, all cubed. Because that's what we did. We made all these indices be equal to 3 by multiplying it like this. So therefore, you have a cube number, and this is 70 cubed. Okay, so we made the smallest number, which when multiplied by 700 to make it a perfect cube, is 490. Okay, so that takes care of number 4, or number 5 at least. And I'm just going to expose this for a short while so you can see that the answer is 490. All right. Okay, this whole thing is recorded, so you can always pause anywhere you want to. Problem number 6, how many fractions between 1/6 and 1/3 can be written as k over 15 if k is an integer? Right, now let's just translate this. You've got that k over 15 is between 1/6 and 1/3. So let's just put that down, 1/6 and 1/3. And k over 15 is between the two. So in other words, it's greater than 1/6 and less than 1/3. You can put them all together like this by saying 1/6 is smaller than this. Okay, now you have an inequality, not an equality. So you can multiply an inequality right throughout by the same number, provided the number is positive. Be careful. In inequality, you can do things like the way you do to equality equations, adding on both sides, subtracting on both sides. Multiplying is a problem where you can't, when you multiply by positive, that's okay. But if you multiply by a negative, then all the signs change, right? The less than becomes greater than. So when you do multiply by a negative, you must be careful to switch the signs also. And likewise, you can invert them, and when you're inverting them, also the signs change. All right. So in other words, I can do this thing in two different ways. Let me multiply by the common denominator. The smallest multiple of all three is 30. So let's just multiply by 30 right throughout. If we multiply this by 30, 30 over 6 is 5. 30 over 15 is 2, so it's 2k. And 30 over 3 is 10. So you want 2k. K is an integer. So which integers are between 5 and 10? But they are even numbers, you see. So 2k must be equal to an even number between 5 and 10. And what are the even numbers? They're just 6 and 8. They say between, so you're not allowed to include the endpoints unless they say so. Endpoints included, they will say so, but it's not said like that. So we have to make it strictly less than like this. So there are two possibilities for k, and therefore the values of k are either 2 or 3. It's 2k. And the question, we have to answer the question, how many fractions? And the answer is there are only two values for k, so therefore the answer is 2. There are two such fractions. Okay. Or you could have inverted everything, and then you'll have 6 over 1 is 6, is less than, oh, now it becomes greater than. Greater than 15 over k, it's greater than 3. All right, so it means that 15 over k right, it must be an integer between 3 and 6, and there are only two such integers. So 15 over k is equal to 4 is equal to 4 or 5. Okay, let's just cancel this. This doesn't really work. Okay, sorry about that. So try not to invert because it creates situations. All right, so I learned something. Okay, so that takes care of problem number 6. Let's get on to problem number 7. So here is the solution. Or there's a different way of solving the problem here. All right, at least that gives you an alternate way. So you can look at that as well. These solutions are in the website, but you can also have a look at the website, and they need not be the same as mine because I usually work it out on my own. And sometimes they will be the same because, in fact, most times, if there's only one way of solving the problem. Okay, now, problem 7. In the sequence below, from the third term onwards, each term is the average of the two terms directly before it. Let's try to understand what that means. It says that each term, this from the third term onwards, okay, let's take that one. From the third term onwards, the third term is B. It is the average of the two terms directly before it. So what do you mean by average? So B now is the average of these two, which means that when you add them and divide by 2, that gives you the average. The average is the sum of the numbers divided by the number of numbers. So there are only two numbers here. So you can add those two numbers and divide by 2. So this gives you, right, when you work this thing out, you get 2b equals 26. And I'm just going to put down 2b minus a equal 26. Okay, I'm not doing all these small calculations. Okay, now they say each term from the third term onwards. Let's look at the next term. So 50 is the average of the two numbers before it. The two numbers before it are a and b. So you'll have to say a plus b over 2. That's the average of those two. So you have that a plus b is now equal to 50, 100 at least. If you multiply throughout by 2. I always like to get rid of as fractions as quickly as possible. All right, so now you've got two equations in two unknowns, and you can see if I add, the a's will die. So let me add so that way I can get rid of the a's, and then I'll have only one unknown and I can solve that. So add on both sides. 2b plus b is 3b. And we're adding because these two give you 0. And then you get 126. 100 plus 26 is 126. And that allows you to go to b straight away. You have to divide on both sides by 3, and you get 42. So if b is 42, then you can immediately substitute in any one of these equations because you now know the value of b. Once you find one value, then you can find the other one. So that is 100 minus b, which is 100 minus 42. So that is the question. Find the value of a, right? So the answer to this problem is A is 58. All right, so yeah, here you can see it's almost the same that I have done, and you can see the final answer is A equals 58. So in case you didn't understand my writing there, you can straight away get it from the clean picture. So now here you got the eighth problem. Eighth problem says ABCD is a trapezium with AB equal to 4 and so on. So all the information is encapsulated in this picture. You got this full length is 11 and one side of the trapezium. This is a trapezium, the opposite sides of a trapezium are parallel. So a trapezium is a four-sided figure where you have only one pair of sides parallel. If both pairs, if these two were also parallel, it then becomes a parallelogram. Okay, so we can, so what is the question? They say the area of the triangle ABP. Okay, so the 12 here represents the area of this triangle. I determine the area of the trapezium in square centimeters. All right, now, so you need to find the area of a trapezium. So let's just write down the formula for the area of a trapezium. I hope you know the formula for the area of a trapezium. It's equal to half the sum of the parallel sides multiplied by the height, the h, which represents the h is the distance between the parallels. Distance between the parallel lines. Because the parallel signs are given 4 and 11. So this is half of 4 plus 11, which is 15, times h. Now we don't know what h is. Okay, evidently I have to use the area of the triangle to get the h. And yeah, now you can see this. This is 4. Then the area of a triangle is half base times height. And let's just draw this height in. So the height of this triangle is from here to here. And that is the distance between the two parallel lines. So this, the height of the triangle is actually h, because it's the distance between the two parallel lines. So this is h. So we can see that the area of the triangle, the area of ABP, triangle ABP, is given. It's 12. But we also know from the formula, it's half. In this case, see, we call it base, but this is really not the base. So it's half one of the sides times the height taken from that side to the opposite vertex. So it's half 4 times h. Here I have an equation here, right? 12 is equal to this. So when you work this thing out, you'll see that this is 2h is 6. H is 6. So the area that you're looking for, once you put the h there, half 15 times 6, half of 6 is 3, and 3 times 15 is 45. Now, since these dimensions are given as squares, you must write down square centimeter. Area is always in square centimeters, and it's very important to write down the units. So this answer to this problem is 45. Let's just check to see whether the answer that I have. Yeah, you can see right at the bottom, the answer is indeed 45. So my calculations were quite correct. Which now takes us to problem number 9. Okay, now problem number 9, it's got a very big calculation here. It's 10 times all these things. It looks quite frightening, but 1 minus quarter, we can work out this thing very quickly. This is 10. Make this 10 over 1 because you're multiplying fractions. So let's put them, each one of them as a fraction. 1 minus a quarter is 4 quarters minus 1 quarter is 3 quarters. 1 minus 1/5, that's 5 over 5 minus 1, which is 4 over 5. Here you have 1 minus 1/6, that is 6 over 6 minus 1 over 6, which is 5 over 6, and so on, going all the way up to here you have 29 over 29, 28 over 29. This is 30 over 30 minus 1 over 30 is 29 over 30. And now you see that a lot of things cancel here. The 4s cancel, the 5s also disappear, and evidently the 6 will disappear with the next one. And here, the 28 would have disappeared the previous one, and the 29 is that. So you got all these numbers. The final answer is 10 over 30. All these numbers have committed fratricide. They've killed their brothers. So at the end of it, the only thing that you're left with is 10 over 30, which is 1 over 3. So although this looks like a very complicated multiplication problem, but you can see the power of cancelling when you're multiplying. See? Cancelling really means you got common factors. 4 goes into this one time, 4 goes into this one time, so you can remove them. See? If you just look at this part here, that is 12 over 20. 3 times 4, 4 times 5, and that is the same as 3 over 5. So it's real equivalence fractions because 3 over 5 is the same as 3 times whatever you like over 5 times whatever you like. In this case, the k is chosen as 4, 3 times 4 over 5 times 4. So that is why you can cancel these things, because these 4 are the k's in this problem. All right, let's just check to see whether this is the same answer as, 30 over 30. Oh, there is a 3 also. Oh, I forgot. You see, there was a 3 which didn't. I'm sure some of you saw that error, but you couldn't tell me. Yeah, there was. I thought the 10 and 30 were the only survivors. The 3 is also a survivor, right? Because it's only the 4s which cancelled. The 3 didn't cancel. Okay, so 10 times 3 is 30. So it's just as well I add the correct answer here. So that can be corrected. All right. So let's just get on to the next problem. Here you've got 4 identical squares, each touch each other. Well, whatever it is, you can see what's happening here. But what's the extra points are that A, B, C, D are the midpoints. So A is right in the middle. So A is the midpoint of all these are midpoints. And the problem is to find the area of this quadrilateral, ABCD. Okay, it looks like a square. Is it a square? Well, if it's a square, then all we need to do is to calculate one side, and then it'll be the side squared. So let's just see whether it's a square. You can't make that assumption, right? Just because it looks like a square, it doesn't mean that it is a square. So let me join this midpoint here to this midpoint here. Okay, so this becomes parallel because they are both midpoints. All right. Sorry, this thing here. Let me be a little bit more accurate here. Okay. So now when you join these, you will see that they become now the diagonals of this quadrilateral ABCD. And you will see that this point where they intersect. Now listen very carefully because I'm arguing that this is going to be a square now. You see where they intersect. This distance here is 1.5. Here is 1.5. Here is 1.5. And here is 1.5. So all these four are all equal. They're all equal to the same length. You can see it. So therefore, you've got four isosceles triangles. But again, because this line is parallel to that line, this must be 90 degrees. Because this is a square, you see. So when you join that, and so clearly you have these two lines will cut at 90 degrees. So you got these little triangles, isosceles triangles, and one of the angles in this is 90 degrees. So the other two add up to 90. But they're equal because it's isosceles. So you'll see that those two are 45. And likewise, everything is 45. All. So that's how you get the four sides. All these angles are 45. So you have a square. And not only that, you can actually calculate this AD becomes the hypotenuse of this right angle triangle. So you have the AD. Oh, anything else to this? Say, okay, the area of each small square is 16. All right. So the area of each small square is 16, which means that the side of each small square must be 4. So this is 4. Okay. So if that is 4, then if you take the area of ABCD, so we've just proved that ABCD is a square, so we can say the area is AD squared, the side squared. Okay, let me just clear out some of these so that I can see what's going on here. All right, so I got this triangle. It's a right angle triangle. And so AD is really the hypotenuse of this triangle. So it will be equal to the sum of the squares of the other two sides. So this is equal to that. Now, what's the distance from here to here? Well, we know that this part here is 4 from there to there. It's the side of the square. And we've got another small piece. But this small piece is just 2 because it's half the side. So here you've got 4 plus 2. right? So, so that side is 6. Likewise, this is also 6. So this is 6 squared plus 6 squared by Pythagoras. I'll just put P, Pythagoras. And that gives you straight away 72. So you got that the area of the square that you're looking for is 72. Okay, that's problem number 10. Okay, now let's just go on to see what the next one is. Let me expose the solution. Okay, so it's exactly the same solution. There's another solution to this problem also. Let me just go back. See, there is another solution where I can say the square is, most of the square is inside the 4 small squares. But what happens is that this part, suppose you take this part which is outside the square that you're looking for, and we push it. These are identical squares, identical triangles. So you can take this and patch it inside here, right? So this goes away now. And here, I can take this, take it out, and move it into that. Okay. And likewise, okay, this is already gone in there. And these. So each of these little things is a quarter of. So join it like that. Then this is 1/8, you see? 1/8 of the square here. And this too is 1/8. So the square has got area 16. So each of these is got area 2. See? So you can, like that, you can take out those two are used up. And then you can take these and you can put it into the original square. And likewise, you can take this one here, for instance, and put it into the original square. So you have that the area of the square is these little triangles here and the rest of it. Okay, so it's actually ABCD, the area that you're looking for. Is actually equal to the 5 squares, which is 5 times 16, right? But then you have to take away 4 small pieces from that, right? From those 16, the area of the outside squares, you've removed those 4 small pieces and pushed it into the square that you're looking for. So those 4 small squares, triangles, they add up to just half the square. So this is 1/8, you see, as you can see. So 4 of them, these 2 will be like that, and those 2 will be like that. So you got those 4 give you half a square, which is 8. So 80 minus 8 is 72. So you could have done it that way as well. It's a little bit more deeper solution without doing any more detailed calculation, but we're just cutting and pasting to see that the areas are really the same. That's a nice strategy because A lot of problems you can solve like that. Okay.